The first of these 3 steps to making our JavaScript scalable is going to be improving your code. This includes writing less code, using good app architecture, and dealing with the UI in a smart way. So let's talk about writing less code. The size of your code can impact performance. And we're not talking about optimizing yet. We're going to talk about that in the next section. We're talking about fewer parts of your code. Parsing that code is part of this bottleneck. And the time it takes to parse your code is not in direct relation to the size of that code. And so literally writing less code or writing in smaller pieces is going to be important to making sure your JavaScript is scalable. Your code is also not necessarily JIT or object cached in all instances. So you might think, once this is loaded in the browser, and especially as I'm pulling this out of cache, I may be getting that benefit, but it still needs to be parsed and just in time compiled in many cases. Especially in the newer engines that can perform JavaScript much faster, it's still doing some optimizations that aren't being cached. An important concept here is that running no code is really quick. So getting up to speed and showing the user what they have an option for and then deferring your operations until the user really needs them is a part of this story. It's going to improve that startup experience by not throwing every piece of code at the user all at once. The user can get invested in a page once they have seen and are able to interact with it fairly quickly. The user will wait for individual parts of your UI to load as they interact with them, and they'll be much more patient in that sense than they will on waiting for that initial page to load, waiting for all of the little pieces to come together. And so making sure that your code is quick and tight when it comes to startup experience can really hide a lot of scalability issues. You should also be using a smart application architecture. And in Module 2, we talked a bit about this in separating your applications into modules and using facilities that are across those modules to do that. We want to introduce a new concept here, and that is layering of your application. Now, you may be using a typical application framework, let's say Angular or Backbone or one of those, to build your application. You will have other libraries that are going to be at the core of what code you've written. They may be base libraries that do authentication or know how to do data access and those sorts of things. And above those, you should have a common facade or an application object that ends up being the cop that all the modules communicate through. And so that as you layer modules on top of it, that as the user interacts with those modules, all the communication is going to go through that facade. And in that way, these are going to be very testable, and you're going to make sure that each of the pieces of your application are going to be very small and straightforward. In this way, when a module wants to communicate with another module, let's say the stock price widget wants to talk to the user widget, it may be simple to make that a tightly coupled relationship because one module wants to talk to another. But we want to stress that, like we showed you in Module 2, that all of this communication should go through a common facade. Whether that's a messaging framework or your own application object, you should never couple these modules together. When we talk about modules, what do we mean? Typically, when we're building web applications, if we take an application like we see here, we're going to start to think about modules as being individual parts of the UI, like we're showing here. So this page may be made up, in this case, of 6 modules that have different pieces of functionality. Whereas the user module may want to communicate with the folder module, they're going to need to go through that facade that you're going to want to use that's going to be the mediator between all these different pieces. The moment you start to tightly couple these all together, you're going to find the performance of your application is truly going to suffer, to where parts of your application are going to be in a wait state waiting for other parts of your application to respond or to do something with them. By going through the facade, you can guarantee that no one is waiting for one part of the UI to react. You can guarantee that one part of your UI isn't waiting for some other JavaScript call to complete before becoming responsive again. In this way, you're also going to want to be smarter about the way you write UI code. The idea here is to be as lazy as possible. This means avoid pre-drawing UIs that are hidden. The idea that you're going to set them to be display:"hidden" means that the size of your DOM is going to be larger. So wait until you need the elements in your UI to actually draw them. If you have drawn HTML and you want to hide it, a good strategy here is to actually pull that HTML out of the DOM so that it's not keeping the weight of the DOM in the browser, but keep the HTML around so you can simply reattach it to the DOM when the users want to show that again. Simply hiding it certainly will make it go away, but it means that the DOM has to consider that as it's dealing with drawing the UI and can slow down refresh rates. It's important that if you do this, you're going to have to manage invalidating your own cache so that as things may change in that HTML, you're going to have to say, oh, this HTML cache is no longer good, let's get rid of it and just redraw it from scratch next time. Recreating an entire section of your UI is often cheaper than trying to do one or two element partial updates. By digging into that DOM instead of replacing an entire section with HTML, you may find that updating the UI is going to be slower, and so trying to do redrawing can be quicker in many instances. Another technique that's important is to do the DOM manipulation without the DOM. And what we mean by that is remove the elements you're going to be manipulating, make the edit, and then reinsert it into the DOM. As the DOM is dealing with a live view of some element, even if it's hidden, as you make manipulation to live DOM elements, it's going to affect the performance and slow down the entire process. And lastly, building up arbitrary HTML and then using inner HTML to shove it in instead of creating one DOM element after another is usually preferable. In this way, your interaction with the DOM is a single call instead of a bunch of concatenation calls. And remember, the first time you insert something into the DOM now has to be aware of being able to display it and deal with different changes. By doing it as an atomic call, you should find that this UI code should perform much better.